So the next thing we're going to look at and we're going to spend a little more time on is what if we don't have this nice form? What if it's just y equals a fraction with some stuff over some other stuff? Well, we have a few different rules. What's nice is the vertical asymptote rule is the exact same. So you're just looking for values of x that make the denominator 0. However, if you can simplify first, like 3x minus 3 over x minus 1, we could factor out a 3, and then these cancel, and we're left with just 3. So this is like y equals 3. When we have a 0, or a vertical asymptote basically be canceled, we call that a hole. So this is something you're going to do more in pre-calc, but for now we're just going to note that a hole exists. But if you were to graph this like in your calculator, you would get a horizontal line like that with a hole. Let's try this one. When we simplify this, we can factor out an x on top and an x on bottom. Those x's cancel away, so we're left with x plus 2 over x minus 1. We would note that since x's cancel away, there is a hole in our graph, but for our graph, we're not really going to include it. Our vertical asymptote is x equals 1 for our vertical asymptote. So this is where things get a little more interesting, is finding horizontal asymptotes. So there's two main rules, but then there's also some rules for non-horizontal asymptotes, so it kind of just keeps going. The first rule, if the denominator has a bigger degree than the numerator, so if the bottom is bigger in terms of degree, then the horizontal asymptote is always y equals 0. So in this case, I do not need to update. In this case, the bottom degree is bigger, so the horizontal asymptote would be y equals 0. We're going to graph these in a moment, but y equals 0 there. If they have the same degree, the horizontal asymptote is the quotient of the leading coefficients. So you'll notice here you have a squared and a squared. So our horizontal asymptote is the simplified form of this, which, since those are the same, they cancel. Our horizontal asymptote here would be y equals 2/7. We'll see some practice with that in a moment. If the degree on top is bigger, there is no horizontal asymptote. However, if the top degree is exactly 1 degree bigger, there's what we call a slant asymptote. To find the equation of the slant asymptote, divide the numerator by the denominator and then just ignore the remainder. Please note, though, you're just going to be asked to recognize that a slant asymptote exists. We're not going to graph any. For your context, though, this is what a slant asymptote looks like, something like this, where you're getting infinitely close to it, but not touching it. And the way we would do that is we would divide this, where you get x plus 3 minus the remainder is 8 over x, but we would ignore that. So x plus 3 is this line that I sketched in. Okay, so all of that to say, we're mainly just going to be focusing on these two rules and then also noting vertical asymptotes. So to graph, you're going to factor and simplify what you can. You're going to find vertical asymptotes, and you're just going to plot points kind of in each interval. So let's just try this one. We're going to factor what we can, so 2x squared over difference of squares on bottom, x plus 3 times x minus 3. Okay, so nothing cancels. Our horizontal asymptote, since our degree on top is the same as the degree on bottom, we would divide 2 by 1, which is 2, so y equals 2 is our horizontal asymptote. That is this kind of rule 2, since the degrees match. Our vertical asymptote, we have two vertical asymptotes because we have two zeros, so x equals negative 3 and x equals 3. So if you ever have two vertical asymptotes, what I'm going to ask you to do is I'm going to ask you to plot some points to the left, to the right, and then 3 in the middle. And please note, this is kind of weird, but in the middle, your line can actually cut through the horizontal asymptote in the middle. It just can't as it approaches positive and negative infinity. So we're just going to plug in some numbers here. If we plug in -5, you get 25 minus 9, which is 16. If you plug in 5 up top, you get 50. 50 over 16 is like 3 point, not very much. Something like that. Let's plug in -4. 2 times 16 on top. And we're going to divide that by 7. You get 4.6-ish. Something like that. We'll plug in 3 points in the middle. 0 is a nice one because you get 0 over -9. That's just 0. We could even plug in like 1 if we wanted to. You really can plug in whatever you want. I'll plug in 1. So you get 2 over -8, which is like -0.25. If you plug in -1, you get the same thing back. So this is actually going to be a parabola. Sometimes you're going to get something that's not a parabola. It might look like an S-bend, either up or down. So that's why we use 3 points. And then to the right, we'll just plug in more points. We'll plug in 4 and 5. If you'll notice, since we're squaring both, you're actually going to get the exact same thing back. So we get something like that. And once again, we're just kind of sketching this out. So you don't have to get super technical on your bends and your turns. Just plot points and sketch out what it should look like. We're going to do one more. I know this video is getting kind of long, but I figured I'd just jam it all into one. For this one, 2x over x squared minus 3x. Well, first thing we're going to do is we're going to simplify. So you get 2x over, factor out an x. And then your x's cancel. So that would be like a whole. But remember, we're not really going to worry about that a whole lot. Our vertical asymptote is x equals 3, because that makes this 0. We don't care about 0 because those canceled out. Our horizontal asymptote is y equals 0, since our degree on bottom is bigger than on top. So we have the horizontal asymptote here. We have a vertical asymptote here. And we're just going to plug in some numbers, and we can plug them right into this equation. So if we plug in like 2, 2 minus 3 is -1, 2 over -1 is -2. Plug in 1, 1 minus 3 is -2, 2 over -2 is -1. This part kind of is going to look like this. That's my phone alarm. We'll plug in 4 and 5. 4 minus 3 is 1. 2 over 1 is 2. Plug in 5. 5 minus 3 is 2. 2 over 2 is 1. So your graph looks something like that. So one last page. This is just kind of your little cheat code. So if when you're working on homework or anything, if you just want to have this page paused, I kind of just put everything in one page. Factor anything first. See what cancels. That's where you have a hole. Then you have your horizontal / slant asymptote rules here, and go from there. So give these a shot. You can always check your work on Desmos.com if you want to see what the real graph looks like and see if you did it right. Or you can punch it into your calculator too, just to kind of check your own work.